Okay. Hello. Hello, everyone. How you all doing? Happy St. Patrick's Day to everybody. And good to see some people have dressed for the occasion. So big warm welcome. For those of you who don't know me, my name is Aaron. I used to work at Go210 with events. And we had our LaunchPad session at Go210 last year, and we're continuing with that. I've started with my own company, AA Studio, and I'm going to continue the great work we were doing with Go210 and the community here in Linköping. And very excited to have Saab as a sponsor for this year to get the community together again in a new place, which is Hulten, which is a bit famous here in Linköping. So if you haven't been here before, a warm welcome here, and looking forward to the evening. And yeah, if you have any questions and you want to connect with me, talk to me. And for those who haven't been to events before, the usual setup is we have like 1 hour of presentations, talks, and then after that we have some pizzas and we have some drinks as well. And we're all sharing, because sharing is caring. So when it arrives, we'll be there. So enjoy the evening, and I want to welcome my friend Olaf onto the stage. Here you go, Olaf. I'll pass you the mic.
Thank you, Aaron. Thank you. Good to see so many people found their way here. As Aaron said, it's our first time here. And I'm sorry about the delay. There was a bit of a technical difficulties there. So that doesn't bode well for Saab, does it? We didn't but at least we solved it eventually. Right. I'm Olof Sundin. I work at Saab Aeronautics with software strategy there. And today we're here to talk to you a bit about, very briefly about aeronautics, I promise you that, okay? Because then we'll get to the good stuff, and that is, of course, the HMI part, where Jonathan will first talk about the evolution of the cockpits, why it looks like it does today. And then, a surprise for you, because this is actually part one. Because next time we have a LaunchPad, it will be HMI Part 2. And if time permits, you may get a sneak peek of that by Gustav at the end, okay? So, and feel free to ask questions along the way. Sometimes we may have to say that we need to move on now, but we will be here after the event for the pizza and the mingle, so you feel free to look us up. We have Jonathan there. We have a few Saab people in the back as well. Wave to the audience. Great. So, very briefly, Saab Aeronautics is Saab's business area for big flying things. I think you've heard them if you live here in Linköping, some of them. It's one of 4 business areas because we also have Dynamics. They make small flying things and things that release small flying things. Then we have surveillance. I think the name says it all. Stuff for surveillance, radar, sensors, things like that. And then we have the final business area. They are about to change their name. They used to be called Kockums. Now they will be called Naval. Also, I think, quite obvious what they do. We were founded in 1937, and Big Flying Things was actually the first thing that Saab did. So the other parts have been added along the way. And we are now more than 7,000 employees at Saab Aeronautics, probably close to 8,000. And Saab in total more than 26,000. So for unfortunate reasons, we have grown quite a lot. We have 4 business units here at Saab Aeronautics. We have Gripen. I think you know what they do. And Jonathan, of course, will show some of that. And then we have Aerospace Systems, and they build parts for aircraft for other companies, for Boeing and Airbus and so on. And then we have aviation services, maintenance and support, things like that for our own aircraft, but also for other aircraft. And then advanced programs. And their job is to look into the future, look into the crystal ball and see what will the next generation of fighters look like. So that's where Gustav works, so who you may or may not be able to hear a sneak peek from today. We have production in Sweden, in Brazil, and the United States. Any questions? Okay. Time for the good part then. So everyone, a big hand to Jonathan.
Hello, hello. Is the microphone okay? Yeah, good. I'll just put this down. So, the pilot's perspective, evolution of the cockpit, and the path to the modern Gripen. I've shown this presentation over 20 times for my wife. She gave me one advice. Please add some more humor. I told her English is my second language. I won't be able to do much humor. Nevertheless, my name is Jonathan Carlin, and I'm head of HMI EF infrastructure, where we focus on the architectural design of all the displays presented in the cockpit. But today, the agenda will be a little bit different. We will deep dive into 3 different sections. First, a quick history of the cockpit evolution. And then we will tell the Saab story, from our first propeller to our modern Gripen. And when we arrive at the Gripen, we will also describe some design principles which had to be taken into consideration when doing the Gripen. So, even the ancient Greeks dreamt of flying. In ancient Greek mythology, Icarus took flight using wings made out of feathers and wax, crafted by his father Daedalus. We all know how that ended for Icarus. However, even the ancient Greeks dreamt of flying. They interpreted their vision of flight using feathers and wax. They imagined how humanity might one day master and navigate the wide blue yonder. Fast forwarding slightly, a couple of thousand years, we arrive at the beginning of the 20th century, and with the Wright Flyer and the implementation of controlled levers. The Wright Flyer was a canard biplane configuration with a wingspan of 12.29 meters. The pilot flew lying on his stomach, facing the front of the aircraft, and steering the aircraft with help of levers. 17th December 1903, Orville and Wilbur Wright took flight and achieved the first sustained control powered flight. What distinguished the Wright Flyer was the implementation of control levers. Before, all the early enthusiasts, they just took off and hoped for the best. Around 1910, the early biplanes arrives. Here we see the initial steps in the formation of the cockpit. Something which resembles a pilot cabin. We start to see a seat for the pilot. The levers have now been changed to a steering wheel. If you look closely, I do not think you can see it, but in this configuration, there is actually one early instrument, and it's an alpha speed indicator, which, when pushed backward by the wind, there was a scale on the rod which indicated the airspeed, and as well the alpha angle, which is the airplane's movement, the angle of attack of the airplane's movement related to a line. World War I, we all know that wars makes the evolution of aircrafts grew rapidly. But entering World War I, and the dream of flight goes from only being used by visionary enthusiasts to entering military service. Initially used in the beginning of the war for mapping terrain and scouting enemy troops, airplanes quickly grew into attack units, bombers, fighters. The pilot now operates inside something which resembles a cockpit. You can see all the gauges and the information. not too detailed information, but there is a compass and there are perhaps something which checks the fuel pressure and so on. But the presentation is there, and the presentation of this cabin was still applicable until the entrance of multi-purpose displays. The next step, World War II. And here we see the P-51 Mustang. First fighter aircraft with enough range and performance to fully escort Allied bombers all the way to Berlin and back. We also start to see a major... What happened with the sound? We also start to see a major improvement of the cockpit. The cockpit is now fully enclosed by a canopy. And there has also been some first early human factor designs, the Basic T. And the Basic T was a British human factor invention. And the new arrangement allowed the pilot to easily scan all the vital information in a T pattern. However, in this model, the P-51 Mustang, the Basic T is not so easy to see because it's more like an L. But the underlying principle still remains the same. All the necessary information needed to navigate the airplane placed at the easy way to scan. And the presentation needed is the heading, how the aircraft is headed, the attitude, the aircraft's direction related to the horizon, the altitude, which height the aircraft operates on, and the pitch. No, not the pitch, the airspeed, sorry. Yeah, aircraft development after war grew rapidly, and a lot of information was needed. And the more information needed, the more instruments were needed as well. As we can see here, the more capable the aircraft became, the more information had to be displayed and presented for the pilot. From the 40s Mustang to the 50s MiG-15, and I took an example of the 60s Thunder Chief here with even some radar displays available. More and more and more instrumentation. More and more and more. 3 examples of very capable aircrafts, but the human factor design, I'd say poor pilot, a lot of information, workload, overload. 1 instrument for each situation, 1 instrument for each capability. Notice on the Concorde here, there are information and instruments on the ceiling. There is even an entire third panel here, operated by a third pilot. In the MiG-21, all the instruments are stacked on top of each other, so the pilot cannot even see outside of the front view. And the Tornado, some people say that the Tornado was when the Western world peaked with instrumentation inside of the cockpit. Because after the Tornado around 1970s, the displays arrives. And what that means is what needed to be presented could be adjusted. It became possible for different tasks to be presented, and you could as well remove some other information. They could share space. With analog instruments, you always needed an instrument, a gauge, somewhere. But with the electronic displays, you could have them changed. How about Saab then? How did Saab, where did Saab start? How did Saab progress? And how did Saab go from a company building train wagons to license-built aircraft? How did we design the cockpit we have today? Hi. Let me go through this, guide it through for you. And we start with the first Saab-built airplane, the B-17. A propeller bomber with reinforced wings to achieve its diving abilities. During that period, you can see all the vital and necessary instruments which were common during that era, but also a Saab-developed bomb sight. I cannot, however, see where the bomb sight is in this picture, but the bomb sight made it so that the pilots could reduce its physical workload. You didn't have to dive straight towards your target with the bomb sight, and that also increased the survivability because it's harder to hit something if it's not diving straight towards you. Hi. Moving on, we have the J-21. J is Swedish and stands for jakt. In English, it's often translated to F, fighter, which means oftentimes air-to-air missions. J-21 had a pusher engine in the back, and also the first Swedish aircraft with an ejection seat. When it comes to the human factor design, I'd say this airplane was perfect. No propeller to block the view outside of the cockpit. However, the maneuverability was not competitive. And one key factor here is when designing aircraft is you always need to balance trade-offs. Good field of vision outside from the cockpit, but worse aerodynamic. So this airplane was not competitive due to its not so good maneuverability. J-29 Tunnan, in English called the Barrel. First Saab airplane to receive a nickname. Also Saab's first jet-driven airplane. What's funny with Tunnan is that there were some clever human factor design. And it was when you had the throttle adjusts how much speed or outset you give to the engine. And when the throttle was positioned just right to achieve takeoff, the pilot could easily with his finger press the landing gear switch, and then the landing wheels would go up. That design is not used in the Gripen today. Today Gripen uses more the standardized landing gear lever, where you have a landing wheel on top of the knob of the lever to indicate that this is used to take out or pull in your landing gear. Next airplane we have is the A-32 Lansen, and A stands for attack, and it's often used for air-to-ground scenarios. First jet-driven aircraft with a twin-seat configuration. The pilot flew in the front, and in the rear seat you had a navigator, which at that time had a radar indicator. So they had to simultaneously cooperate with each other, and that's always difficult in oftentimes quite hectic scenarios where you need to make split-second decisions. But it was many people in the Air Force, they liked the Lansen. The HMI or human factor design is, I'd say, not so Saabish. It's more resembles the other version called I think it's called the Thunderhawk. I'm not sure. My favorite, J-35 Draken. Saab's first supersonic aircraft, and the first one used in the Western Europe. With Draken, there were some major improvements for the pilot as well. Data links started up here, and the stridsledningssystem 60, which was a tactical system which made it able to share information between early airborne warning control systems and as well the command operating center. For Lansen, the radar indicator was placed in the rear seat, but with Draken, because this was a single-seated aircraft configuration, the radar indicator was available in the front seat. One thing with Draken is that Saab also developing simulator to improve its design. You could iterate the development in a simulator. The Air Force also did some modifications with Draken. They changed places where some wheels to turn on and turn off different types of weapons. And one key factor here is it's always good to iterate your design. If you can iterate your design, you can improve your design. So either at the development, during development in simulators, or even together with the customer. If we look closely on the picture here, we can also see that during the 60s, they were very fond of bar charts. If anyone has driven an old Volvo Amazon, they look pretty much the same. Viggen. With with Viggen, hard to say in English. With Viggen, Saab takes its first step into the digital era. Centralkalkylatorn, I haven't found a English translation for it, if it's the central calculator or central processor, or I think you understand what I mean. Was a major step to help improve its processing capabilities. It helped the pilot with processing the flight control system, and as well some navigation sensors such as the instrument and landing system, which is a radio navigation system which helps the pilot, assists the pilot with navigating and landing. Viggen was also the first aircraft where you went from what does the equipment do to what does the system do. Before it was, what is this equipment? How do I operate it? Until the entire system. HMI, the organization I'm representing, which is responsible for all the usability, how can the pilot operate the airplane, became one single design organization. Before we had each different equipment had its own, each subsystem or each different equipment had its own design organization. How will this equipment behave and how will this equipment behave? Viggen had, I believe it's the world's second, we were second in the world to implement head-up display. There was also a TV sensor tube, if you see up there in the right, to help and assist the pilot with a TV-seeking ground missile. And the mission support system and the data transfer unit was as well a big game changer for the Viggen. It made it possible to pre-plan your mission and then transfer it and load it into the computer. And then you can have more complex tactical scenarios to assist you. We okay with time or? Yep. Viggen gets a midlife upgrade and introduces, in Swedish it was called the Jaktlänk. I believe the English translation is fighter link. Jaktlänk is the same as the nowadays NATO standardized Link 16. I'm not sure if you heard about Link 16, but it makes it possible to share tactical information not only between the aircraft and the operating center on the ground, but between different aircraft as well. At the beginning between 2 Viggens, and later on between 4 Viggens. You start to notice as well that some early, more electronic displays starts to appear. Here we see a tactical indicator which represents a map, and to even further help the pilot with the tactical decisions. Prater is introduced, and it's a voice synthesizer to help and assist the pilot with commands. Another funny thing which Viggen implemented is the knife, which uses tactile, I think it's called in English, tactile presentation. So the knife was from the joystick. The pilot received feedback if the system believed that the plane was beginning to stall, or if the pilot pulled too much G-force. So the pilot got stabbed in its hand to indicate reduce joystick input. So sometimes you even need to use all your senses. An evaluation system appeared as well. And it's always good to, after your mission or your training scenarios, to evaluate how did this scenario, did it go as planned? After Viggen, we enter JAS 39 Gripen. And with its first version, the Gripen A and B. A for the single-seated configuration, and B for the dual-seated configuration. Gripen introduced fly-by-wire, and it's a computer-controlled flight system which makes it much easier to navigate and fly the airplane. And what that means is, if it's easier to fly your airplane, the workload is reduced, and the pilot can focus on other important things. Gripen is a multi-role fighter. JAS is Swedish, which stands for Jakt, Attack, Spaning. In English, it's translated to, I'd say, fighter, attack, reconnaissance, which means air-to-air, air-to-surface, air-to-ground, or scouting, or spying, or doing reconnaissance. And with the implementation of a multi-role fighter, you need to make some key presentation decision. For example, have one HMI regardless of mission. Don't confuse the pilot with different types of presentation depending on the mission. Keep it simple. Don't present too much information all at once. Help the pilot, assist the pilot with thoroughly thoughtful mental models. And to reduce reduce the information overflow. If you don't need the information, don't present it. Don't show. And the implementation of multi-purpose displays also made it possible to adapt what was presented for each different type of scenario. Raster images was introduced as well. And the HUD got holographic and wide-angled. One design principle, uniform design. Here we see the presentation on the HUD. This is in the air-to-ground scenario, and this is in the air-to-air scenario. And the presentation is very similar, very uniform. And it's designed in that way to not make the pilot change how they interpret all the symbols. The pilot does not need to think, oh, why am I doing air-to-air, why am I doing air-to-ground, what does this symbol mean? It's all uniformed and easy to operate. Some mental models were introduced as well to help the pilot with its workload. In this case, how to handle and navigate the aircraft. To make it intuitive, how the pilot moves related to the outer world. In the picture here we see on the left, this is how the presentation is displayed on the head-up display. Consider yourself surrounded around a sphere. And when you fly straight, all these spheric lines, the attitude lines, are straight. And in this scenario, we're currently climbing. And to get to the horizon line and fly straight again, you want to make the attitude lines or the spherical lines go straight again to help the pilot with some mental models. On the right there, you have the presentation to assist the pilot with navigation on the head-down display. There the pilot observes the sphere from behind, but the principle is still the same. Support expectation and standards. Remember the basic T, all the vital information placed in one easy way to scan pattern. Implement that as well, because most of the pilots, they've flown aircrafts before, and they do not want to relearn everything. We want to enhance it, and we want to get all their experience and make it easier to fly this airplane as well. So in this case here, we have the head-up display. On the top, there is the heading. On the left, we can see the airspeed. On the right, we see the altitude. And in the middle, you can see the attitude, how the airplane is related to the horizon. On the right, it's on the headed-down display. And in the Gripen AB version, sometimes they called it the Mickey Mouse. But on the top of on the upper left there, you see the airspeed. Upper right, you see the altitude. And in the middle, you see the heading and as well the attitude. Design principle, direct format. When the required action is clear in a dangerous situation, use direct commands. Commands related to flying and navigation uses a male voice. Commands related to more tactical scenarios uses a female voice to even further distinguish if the command is related to flying or if it's related to the mission. The next update of Gripen was the Gripen CD version. Still, all the previous design principles is applicable, but with the CD version, interoperability became the primary focus. Swedish was removed as the primary language, and empirical units were introduced as well. Empirical units are the standard units when it comes to aircrafts. The displays were updated with color displays, with a possibility to adjust day colors or night colors, depending on what the pilot preferred, or if the pilot flew during the evening, they don't want to have too bright colors. The backup instrument was replaced with an emergency mode, integrated inside of the system. The design principle don't need, don't show. In the Gripen AB version, all the backup instruments, they were always visible. On the top there you see all the vital information needed to operate and fly the airplane. With the Gripen CD version, the backup instruments is only visible on demand. It's integrated inside of the system. If the pilot does not need the information the backup system gives him, remove it from the display to reduce the workload. Direct useful format. Make it easier for the pilot to understand the information. With all the gauges and meters, the pilot had to read every different gauge and check it on the map to understand T equals 24. And what T equals 24 means is that it's the play time. It's the time the plane can stay in the area given by the current fuel consumption, current fuel, and how far you are to your nearest landing base. Present it in an easy to understand number for the pilot. You can play around here for 24 minutes, then you need to go back and land. We can also see here in the picture B plus 48. And B is used as bingo fuel, and it's the minimum amount of fuel needed to immediately abort your mission and return to the closest landing base. And here you have B plus 48. In that scenario, 48 is 48% extra. And M plus 24 means you have 24% extra to fulfill your mission. But the most important part here is the 24 minutes. Just give it in an easy to understand number. We now enter the Gripen EF. And one crucial part with the Gripen EF is the first slide here, the separation of flight critical data and mission critical data. Flight critical software has a lot of processes and regulation. Mission critical data does not have that many regulations. If you manage to separate those, remember with Draken, you can update the system faster. And hopefully, if you update it faster, you can make the system better as well. With JAS Gripen E, Gripen goes from a multi-role fighter, where you have an aircraft which can do different types of mission, to an omni-role fighter, an aircraft which can do different types of mission simultaneously. With a wide area display, the big display presented in the middle of the screen here, or in the middle of the cockpit, not the middle of the screen. You can set up your presentation as you like. You can make it flexible. You can easy shift focus. You have different types of layouts and region handlings to enhance what's important, and perhaps to don't show what's not at the moment so important. Gripen EF received an upgrade with multiple sensors, and the same with the direct useful format. With all the sensor make the sensor fusion fuse and merge all the different types of sensors, and present it to the pilot in an easy to understand format. Much harder if each sensor gives and presents its different information. The pilot has to merge all the information and then get a good opinion of what the system wants to tell the pilot. So for example here, overview and details. With a wide area display, the pilot can get a good overview, but at the same time, with all the region handlings, get into the needed specific details. Here we have a tactical scenario, and the pilot wants to have some extra information regarding what's ahead of him. Another design principle, show only what's necessary. In this case, I believe there are 3 different types of scenarios. To the right, I'd say it's a normal standard ferry flight. You're relocating from one base to another. You're moving in the civilian airspace. You don't need to have too much tactical information presented, only some vital maneuvering and navigation presentation. In this scenario here, perhaps you're flying into an airspace where you do not know what's ahead of you. You want a good overview. You want to see everything. And given that perhaps the system tells you that there's something which is of more importance, present it and make that a priority. Still keep everything else visible, but add what's important. And to even enhance that furthermore, enhance the most important. In this example, enhance it to the desired size. If needed, keep the vital information, if necessary, or else remove it. But assist the pilot with what's important, and don't show the pilot what's not at the moment, currently not so important. So, is this the end? Or, Gustav, will the cockpit in the future be empty? Will you have AI co-pilots? Will there be even the virtual displays with even more augmented reality? I'm not sure.
You need to talk in the mic.
Nevertheless, thank you.
Yes. Yes, it's a little bit sneak peek to the next time Saab will get here. We will take the part 2 of the HMI. Here you have the evolution from the historical perspective to where we are today. But also at Saab we are looking for... All right, now it's better. We are looking for what will be after Gripen and what will be in the upgrades of Gripen. And of course, everything I've said here is valid, but there are new aspects that are adding up. We will be, up till now, I will say that we are typically, as a pilot, we're controlling our own aircraft, our own weapon systems, our own sensors, and then we can get help a little bit from our friends. as you said, with the fighter link. That perspective will be even more enlarged. You will be able to control like resources on your friend's aircraft. You will also possibly have unmanned aircrafts, and they will not only be like automated or controlled by and radio controlled aircraft, they will be autonomous. So they will make own decisions. If you get shut down, they will be able to finish their mission and then return. So typically, how will you interact with these autonomous unmanned aircrafts? That will raise new questions. You will have to issue transparency, intentions, and you will also deal with hallucinations. So it's you are in a larger context, and there are new questions that are arising. So we'll talk a little bit more about that in the next session.
Does anyone have any questions or?
Yes, we do have time for some questions. So
Yeah.
just raise your hand, or Aaron, you can check if there are any questions online. We can add those as well.
Yeah, I can put it down as well. Yeah.
Right. Yeah, we have a question back here.
Yeah, so my question is regarding other capabilities beyond the heads-up display, or maybe this was more intended for just questions about the heads-up display.
Oh no.
No?
Go on.
All right. So, what regarding the question of what's in store for the next generation of fighter planes developed by Saab? There's a lot of talk about different generations of aircraft. So you have 4th generation fighters, 5th generation fighters, and the primary distinction between them is the concept of stealth.
Yeah.
Is that something that is interesting to Saab to work on and develop, or is that something that is not worth it and would just make the whole thing too expensive, and instead maybe you want to focus on something like controlling drone swarms and other networked warfare systems?
Good question. When it comes regarding, I think Gustav can answer, but first it's as balancing trade-offs. Oftentimes when you speak about stealth, it's only the stealth coating. There are other ways to achieve stealth capabilities. But Gustav perhaps had something more to add.
Sorry if I interrupted you, Jonathan.
No worries.
But I would make the same answer as you. Stealth is not 0 or 1. It's like if you measure how aerodynamic is a car, it's on a scale, and it's the same on aircrafts. Yeah. But when you look on aircraft, you can see some ones are boxy and others are more sleek, and then you say, it's boxy, it's a stealth, and it's the 6th generation. But they are also visible. It depends on what you measure. Yeah. They're good on radar signatures to not reflect them, but you can have other sensors. And if you see a sleek aircraft, they also have materials that reflect sensors. So it's not so easy that an aircraft is stealth or not a stealth, but to take a decision early in the design if it should be boxy or not, because the box has some advantages, but also different disadvantages, of course. I don't know if that was answering your question.
Thank you for your question.
I think we had another one back here, right?
I was interested when you talked about that you only see the gauges that are necessary or that you need.
Yes.
But in different scenarios, you probably need very different information.
Correct.
How is that adjusted? I'm just interested. See.
Either the system automatically presents the needed information, depending on what the decision supports, tells the system to present, or the pilot can as well press different buttons to make that presentation appear.
Okay, yeah. Maybe we'll take one in the front and I'll come back to you, okay? spread it out a bit and get some exercise as well.
Hi there. Thanks so much for the presentation. I think I'm right in saying the Gripen is doing quite well in the export market. There's been quite a few high-profile orders for it. To what extent is this adaptability of the cockpit to different pilots a concerted effort to make it more exportable?
Oh, good question. Jesper, do you have an answer for that?
I'm thinking.
Yeah.
No, but of course we have to take all the different kinds of aspects of a pilot into account when we do the try out the cockpit for each customer. So we can do some adaptations, of course, but yeah, they are. You've seen the cockpit is pretty crowded, so you can't do everything in the world.
You can manage it in sort of a way together with the update of the software. I'd say you can make it more a variant configuration, depending on the customer preferred preference on what type of loads they're carrying and so on and so forth. But yeah.
Yeah, and also since we have the wide area display, we can actually, when you plan the mission, you can even choose your favorite layout of the potentially at least of the wide area display. I want a big map and some small instruments, or I want a big radar and picture and so on. So you can actually pick and choose how you want to lay out the wide area display at least. Okay, anything else? Yes?
I have a question regarding there is a lot of human doing the action, but is there any plans on doing the opposite so that the system understands how the human think? Basically predicting the eyes are moving towards this region a lot, and in that way catch a behavior.
Good question. I'd say you always, how to say it? You always want to predict how the system behaves before you need the human interaction. And nowadays we're currently moving so rapidly that the system can make some major decisions even before you yourself knows that this is the preferred action. But you always need to balance who makes the final decision. The system can only give you this much information and guide you to tell you the preferred decision is to do this. But in the end, I'd say there is still a human which tells the system, okay, let's do it. When it comes to more perhaps the tactical scenarios. Yeah, was that your... No,
Yeah, and we had another one back here.
Hi, I have seen the Yes 39 have like a big touch screen. So will like a touch screen be mission critical or reliable in real situations? Because we know sometimes the touch screen could fail when there is some water in your hand or something.
Yes. Hopefully there won't be too much water inside of the cockpit and something has been, an error has occurred. But the touchscreen is, how to say it, you can use the touchscreen, but you can always use a supplement as well. You never implement that this function will only be possible to achieve if you use the touchscreen. You always need to have a backup plan. How can I do the following without, let's say, if the touchscreen is broken? The touchscreen is for to further assist the pilot with perhaps easy map out, prioritize this area or something.
Right, and I think we had a question online, or do you take one from the audience first? Yes, okay.
Thank you. Do you factor in anything about accessibility or like eco-driving and such things into the designs?
You mean the sustainability with regards of...
Yeah, like environmental.
Environmental, yes.
Or
I'd say...
resources you use.
Ooh. My honest, Gustav might answer this one. Yeah.
I would say, because you want to have as long range as possible.
Yeah.
We recommend flight range was because you want to have the best range with the fuel you're actually bringing. And then you said accessibility also.
Yes, for example, disabled pilots.
Yeah, we have there is a pilot specification that the cockpit needs, and that specification is set up by our Swedish customer, and it shall meet typically 90% of. I'm sorry, but 90% of the male population when it was formulated and specificated in the early 80s. I can say now when we look forward to the next generations, we have a wide specification that also have women to meet their needs. But we typically have disabled, that's not in the specification. But of course, it's important to have that we have good accessibility in the cockpit. Also, if you the whole you have redundancy.
Thank you.
And also, actually, Gripen was the first fighter aircraft to fly on sustainable fuel. So, yeah, it can actually do that. Do we take another one here or online? Another one from the audience? Good. Many questions?
Well, this is a short one. You didn't mention helmet control, that you can use the helmet.
Yes, the head-mounted display, yeah. You have the presentation available as well on the helmet, which gives you navigation presentation, and it also gives you tracking positions and so on and so forth, which also assists and helps the pilot to receive presentation.
Yes,
and information.
when it's tested tactically, I know that it is preferable even.
Yep.
Okay, an online question?
Great. So, first question is Saab making these fighter aircrafts for profit-making motive, or is it driven by Swedish self-preservation factors?
I think
I would say it's both. Actually, there is not one single fighter in the world that is made, only on commercial grounds. Let's try and build a fighter and see if anyone buys it. That's not how it works. You always have a country behind you, which is the prime customer. But having said that, we also obviously want to make money, like any other company, and also in order to be able to build the next generation of fighters and so on. So it's both. But like I said, no fighter in the world is ever developed without a country behind them.
And I also comment said that wonderfully presented. So, and also they want to know, when is part 2 scheduled for?
Gustav.
Well, that's actually secret because this is military stuff. No, actually we haven't decided, but it will be towards the end of May or the beginning of June. That's about as much as we know right now. So sorry. So in other words, we'll be announcing the next one very soon. So I think most of you know me or follow me, so you'll find out when the next one is as well. So just stay tuned for part 2 of that. But that's all the questions online, and but we can take more questions from the audience because we're still waiting for the food to arrive. So use this time while you're waiting. We have one. Okay, I'll pass it. I'll come to you. Here we go. And if you could just pass it around.
Yep. Thanks for the presentation.
Thank
Very
you.
good.
Thank you.
I have one question about, like, this might be a little bit ignorant because I don't know the industry that well. But how much is that kind of interface unified across different fighters, and how much is, because you mentioned different pilots fly different planes. I assume some of that is like same, but as well you need some, as you said, like fighting other jets, you want your better somehow as well, as part of that is the interface, I assume.
You mean how the presentation is compared to other types of aircraft?
Yeah, or controls and everything.
I'd say, first of all, I think all the how to present the primary flight data, believe it's mostly the same, because if you go back even to it's still like back in the World War II with the basic T. That's all the vital information needed to achieve the primary normal flight. And most of that data is used by as well in the civilian airplane industry. When it comes to how to present all the tactical decisions, I think that's more depending on each company and how they want to present it and what they want to do with the system. So to give you summarize, my answer is when it comes to normal flying, I think the presentation might be very equal, but when it comes to the tactical presentation, they might differ a lot, because there also you do not want to share that type of information too openly. It's easier to share. Yeah, Gustav?
Exactly as you say.
The microphone, pass it around.
It's up to each company. There are no standards we need to follow or no regulations we need to pass when it comes to the tactical information. But NATO has a standard, and we try to follow that standard. It's mostly on details, what colors, lines, symbols to use. So you should be aligned in NATO with like how tracks enemies are displayed.
So many great questions, I think, that got me thinking about things I've never thought of before. So I came up with this one, how does AI factor into this? I know buzzword, but still it's relevant, I guess. And do you plan on incorporating or maybe do already machine learning for to suit the individual pilots even better than maybe you already do, like the GUI and the I don't know patterns, which relates to what the gentleman next to me asked before. Yeah.
Good question. I cannot answer what we're planning to do because of obvious reasons, but I can answer that last summer we flew with AI which navigated the airplane. Not sure if you saw it on the news. And as well as you said in your question, AI can help you to sort out data and so on and so forth. But if Jesper doesn't want to say anything, I think I cannot get into too many details what we will do.
Yeah, I agree with you, Jonathan. But we will, with new exciting technologies, we will leverage them as needed, I guess. So we will see what the future brings.
Okay, anything else? Are you all hungry for pizza? Well, at least one more.
Thank you. I'll sneak in a second question right here at the end before the aforementioned pizza. I was thinking about the availability of information, because we were talking earlier about accessibility if the pilot gets injured. But what about if the plane gets injured? How a liquid crystal display can be fairly sensitive to impacts and other such disturbances, not to mention electronic interference and that kind of stuff. Yeah. How do we make sure that a pilot can still navigate home in case that all the heads-up display and all the fancy electronics stop working?
You always take the system safety and the probability of failure into consideration when creating an aircraft. You have redundancy, which means that if this display is broken, you can get the information on another display. Well, there might be a scenario where everything is broken, but then you at least can use the ejection seat and pull yourself out, and get yourself out. But you always take the redundancy into consideration. And very experienced pilot actually does not need too much information to be able to fly and land the airplane. But that's how we take care of if anything gets broken. Redundancy. Gustav.
Sorry, but also to add, these displays are not like the displays you buy on Elgiganten. It's the most robust displays probably ever designed and manufactured, and they are very, very well tested before they even get to the aircraft. So already in this design phase with temperatures and with G-forces and so on. And as I understand, you can actually shoot with a machine gun in a display and it still works. Not the whole display, but part of it. And also if you get your power supply down, you have emergency batteries behind. So as Jonathan mentioned before, I don't know if you noticed, but in the early Gripen we had what we call the iron instrumentation, the classic ones, but now they are the analog. They are removed because we fully trust in the crystal displays, so we have the confidence to remove them. And actually, it's what aircrafts look like today. But the Gripen aircraft was the first one in the world to remove the analog instrumentation.
The plane will break before the screens.
It's also robust. No Gripen have been shut down yet. I know also if your display for some reason it will restart automatically. So I've never been to that the display actually the display that it get black and never get back. Never happened yet.
Thank you, Gustav.
No, actually, no Gripen has ever crashed because the avionics system failed at all. So it is robust, definitely. All right. Any news on the pizzas, Aaron? No? Okay, I think you fooled us here. There's no pizza coming. So we can do part 2 right now, Gustav. Okay.
Keep the questions going. Yeah.
I'm thinking about if any of the gauges break, how many are there? At least 2 backup systems, I guess, or more.
There are several backup systems depending on what type of thing which breaks. That's all I can say. But there are
at least 2.
At least 2. There's only one engine, but.
So another AI-style question, but this time I believe there are systems we can estimate what a human would be looking at given a screen display and so on. Is that anything useful for you guys in the development process?
Very useful. You mean like a heat mapper or something?
Yes, something like this, right?
Of course it is. It's super useful.
Is it something you do use already?
I cannot really tell you.
Fair enough.
But it's very useful.
One up here, right?
I guess I have a question. If the pilots get unconscious, maybe, or something like that, shall we have an autopilot activated, or what happened then?
What happens if the pilot gets unconscious? There's a prize. Good question. I think the answer now is we have some problems. Yeah.
Yeah, but I mean, if at least we can say that in contrast to an old aircraft, if you just let go of the controls, it doesn't spin uncontrollably to the ground.
Yeah, the fly-by-wire system helps you a lot to actually fly the
And
airplane.
if you're about to crash to the ground, the plane will also avoid that. So you will keep flying for a while until you run out of fuel.
Yeah. Any other questions or?
I'm a little bit interested. How is the noise redundancy in the cockpit? Is it a lot noise? And if it's not, could one potential next step become to use natural language to also steer the aircraft? I'm thinking of Star Wars now.
Yes.
Speaking to the aircraft and it understands and predicts.
Using voice to give commands.
Exactly, preparing the system via your voice, basically, using transformers. for that?
Could be done. Has been studied a long time ago, and is still been doing studies. So that's a possibility.
Sorry, I like to talk. But it has been in fighter aircraft for like 20 years, but it has not been very successful. So we have never introduced it in Gripen, but we have also been studying it for like 20, 25 years. But none of our customers have wanted to buy it. So therefore it's not in the aircraft. And there are reasons for that. But also we have been studying like natural language, and we see greater potential with that. And I guess that will come more in the future. That's what we see now. So I guess I have been talking about half of the part two already.
Okay, an online question.
Yep. So, question, how much data from Saab is fed into AI servers and platforms?
Wow. Good internet question. Who is the source of that question?
He says he's not spying.
It's not, yeah. A lot of
Then it's okay, you can give all the details.
Then I can, I do not have that information, I'd say. This business is often very hush-hush and need to know. So, and that type of information I do not have. I'm sorry.
Okay, anything else? Any more questions? Yeah, one over there.
Do you outsource any parts of your product to other companies, or is everything done mainly at Saab?
Most of our development are done by Saab, and sometimes with cooperation with other companies.
Yeah, and also, but much of the equipment is from suppliers around the world. So we don't build all the pieces of equipment, things like that.
Integrate the equipment, and all the development some are produced together with cooperation, I'd say. Cooperation.
So one example of this is, you talked earlier about that we flew AI in Gripen last year, right? And that comes from some collaboration with the German company Helsing, where they developed the AI agent and then we integrate it into Gripen. So that's one type of collaboration.
Yeah, regarding the components, and I see you immediately grimace. I cannot tell you that. No, the actual embedded systems that are running within the Gripen, I imagine that there's thousands of sensors all over. Are they mostly built within Western countries, or are they from farther east?
I'm not sure about all the sensors, but I'd say most built together with Western. It's not the part of the HMI, so I'm sorry, I do not have that straight.
But do you have limitations on?
We consider closely who we buy from, okay? Let's leave it at that.
I have a question. So if you want to run a very powerful AI, perhaps you need the best chip, which are like a few nanometer technology. And however, those kind of chips are much more easier to have errors, especially when there are interference signal or short wavelength signals. So in the redundancy-wise, you perhaps will prefer to use larger size technology to make the chip. However, that consumes more energy and not let you run a more powerful AI. But it does provide you more redundancy. So how does that select in this scenario for a fighter jet?
I'd say either you have two of those smaller ships, so you have a federated system where they perhaps do the same task, and then if something fails, then you have a backup. Or you need to very thoughtfully think when do I want to use this? Do I want to use it in the extreme flight critical scenarios, or is it more towards doing some information and observing? That might be the answer.
Okay. Yeah, of course, in the other end.
You're going to regret it after my question. Hi there, it's me again. Can I ask a non-aircraft question?
A non-aircraft question, yeah.
As Aaron said, it's St. Patrick's Day today.
Yeah.
What is your opinion of the Irish and why?
I'm very fond of the Irish, I'd say. Luck of the Irish, yeah.
Yeah, great bunch of lads. And a follow-up question. Can Irish people be pilots?
Can Irish people be pilots? Is this a joke or? Of course they can.
I don't actually think they have their own air force, though, do they? I think they rely on the. No, I think they rely on the.
I knew who built Titanic, and how that went.
Very different disciplines.
Naval.
Okay, any questions not relating to the Irish people?
I have too many questions, but I'll try to limit myself, at least until the pizza comes.
2 minutes. Yeah.
2 minutes, okay. All right, then I'll talk for 90 seconds and I'll give you 30 to answer me. No.
Fine.
We've talked a lot about the instrumentation and the actual airplane itself. I was wondering a little bit more about, if we pull back a little, what is the what does the development cycle look like for like upgrading the actual software that goes into the Gripen, and or even the hardware for that matter, like with new upgrade packages? What are the different timescales and requirements? Like how many people does it take, and so on?
The design process.
The design process and the actual implementation, software and hardware.
Jesper, he's actually head of development management at HMI, so I give that question to him.
Yeah, and I'll just stay clear of numbers, even though that would be the most correct answer. It's of course different cycles. Hardware, longer cycles. Software, shorter cycles. So that's basically how we perform the development, that we try to plan accordingly.
But is it some sort of continuous integration into the software, or is it like upgrade packages?
It depends on what type of contract you have with the customer, of course. But yeah, it depends. Yeah.
But it does depend. It's not a standard.
Exactly. So yeah.
Yeah, but you can say at least that thanks to, I mean, we mentioned before that the system is divided into a flight critical part and a tactical part, which allows us actually to integrate tactical stuff rapidly and have it ready to ship to the customer. So should for example, in an emergency or in a time of crisis, we will be able to very rapidly update the system. But like Jesper said, sometimes the customer doesn't want a different aircraft every day. So. Yeah, code in the morning, fly in the afternoon.
Okay. Hi. I was thinking an aircraft is expensive, and so is training a pilot too. I guess like very expensive. But talking about AI or complementary systems, I mean, one could start thinking about replacing the pilot, of course. And then I was just curious, like, what is, I don't know if it's possible, but what's kind of the ratio between the aircraft's hardware and like a human pilot in terms of expense? Like the Ukraine, for example, has had a problem with getting enough pilots for new planes. So is that enough for a question to get some response? What do you say?
I think first the question is, it's very ethical.
Yes.
How do you value a life?
Of course.
But I'd say you need to train a pilot, and the pilot needs to get back from the mission.
Yeah.
If the aircraft doesn't get back, well, it's loss of money, and hopefully we have more aircrafts available. So currently, you always value your pilots a lot, but I cannot set a number on on it.
Okay, thank you.
Thank you.
Well, The pizzas have finally arrived, so we don't need to squeeze any more questions out of you. Nice, right? But like I said, the people from Saab, we will stick along for the pizzas and the drinks. So please approach us if you have any more questions. Thank you, Jonathan.
Thank you, thank you,
And
thank
you.
Tack så mycket, tack så mycket.
And I hope to see you again in a couple of weeks when we do part 2 of this. And hopefully the pizzas will be on time at that time. So.
Okay, thank you, everyone. I'm going to let you go now to get the pizzas. I just wanted to do a few things, but just say thanks for coming out tonight. And yeah, it's been really good to see a nice turnout. We're also here in this building. We're having another event on March 26th. This time it's with the women of Saab, who are going to be doing presentations here. It's from the different Saab business areas. So if you'd like to join for that, you're very welcome. I'm also going to be taking some photos and videos for promo. So if you don't want to be in videos, just say to me and I will stay away. So now we're going to have the pizzas, and you can be in this area. We're all sharing. You can also be in the cafe as well. We probably have about, I think you need to be out about 7:30 or 8 o'clock at the very latest. So just word. So thank you for that, and enjoy the rest of the evening as well. Thank you, and thank you, Saab. All right.